Yeah, 1 and 1 is 2, and 2 is 2 is 4. 3 and 3 is 6, so now let's try some more. 4 and 4 is 8, and 5 and 5 is 10. 6 and...
Hey math lovers, let's go over the Module 2 test. February 17, 2022. Complete the sentences, describe the N behavior. When you see the word N behavior, you should just be looking for arrows. Well, let's draw a sketch of this one. This is a odd, use a pen, odd degree. And the easiest odd degree we know is x to the first, because 1 and 3 there are odd. So that one, when it starts down, ends up going from left to right. This one's called our leading coefficient. If it's positive, like 5 is positive right there, then these arrows here stay the same. So basically my graph's going to look something like this. It is a power function that just basically means there's nothing else over here and it goes through the origin. Okay, so now I need to determine the N behavior. So this is x, this is the y, or we also call that f of x. On the x-axis, these are negative numbers. We call that negative infinity. Over here is positive. Down here on the y-axis, or f of x, those are negative numbers, and this one is positive. So going from left to right, I see that the graph is going, well, let's read this one. I know they do it kind of backwards here. As x goes towards negative infinity, so this is going towards the left, what happens to my graph? Well, if I go towards the left, the graph or the arrow goes where? Down. So that would be negative infinity is my answer. As f of x goes towards the positive numbers on the x-axis, that means it's going towards the right. There's my arrow. That means it's going to positive infinity would be our answer. Okay, this is the question. And I call these response numbers. For which does the range only include values of f of x that are greater than or equal to 0? Okay, my phrase for range is going from the bottom to the top. So if you draw this one, this is an even. Even's going to look like this, right? Like x squared. It looks like a parabola. And the range means going from the bottom greater than or equal to 0. So notice how the graph actually starts here on the y-axis 0, and it keeps going towards infinity. So the range, we would call this in interval notation, negative infinity to positive infinity. But in inequalities, we write this as on the y-axis, the values or the answers are bigger than or greater than 0. And that matches that one. So that's this one. Okay, I'm going to put a check mark. Let's go through the other ones to make sure. Okay, so this one has a negative leading coefficient. And this one would be, oh, excuse me. The range on this one would be 0. Okay, so the range on this one is bottom. So you're starting at negative numbers, but you're actually stopping at 0. Negative numbers, but you're stopping at 0. So this one is actually y is less than or equal to 0. It could be 0, it could be negative 1, but this one is greater than 0, so that's not this one. Letter C is this one is a odd, so it's going to look like this. And anytime you have the two arrows in separate locations, this is going to be negative infinity to positive infinity. And in the inequalities, you're going to say all real numbers. Because the y's or f of x is the output, where the answer is. So it's not this one. And let's try D. That would just flip it, so then your arrows are over here, Same thing, going from bottom to top, you're going from negative numbers, you're hitting the graph, and you're hitting all the positive numbers, so you could basically have any answer. Here's another cool symbol for all real numbers. Looks like a parallel R there. And our correct answer is A. Okay, use a function f of x equals 2x to the third plus 4x squared plus 5x minus 7 to complete the following sentences. The degree, okay, let's look at degree. The degree is the highest exponent. So this one, I'm just going to write it. This is 1. This is x to the 0. So the highest degree would be a 3. So response number 4 would be C. The leading coefficient is like a leader. It's in front of the highest degree. So this one is nice because it's already in descending order. Here is my leading coefficient. It is positive. It is a 2. So response number 5 is B. Number 6, the value of the function where x is equal to 0. So let me just draw you a quick graph, and this is what we're going to learn actually next chapter in some ways, but more detailed. Okay, so I know my graph is to the third power. The leading coefficient is positive, so your graph's probably going to look something like, I don't know, it goes through -7. Might do like a bounce, and then goes through. Okay, something like this. And then it's saying where x is equal to 0. Okay, well, where is that number? -7. How did I get that number? Well, I put in 0 for x into that function. And if you've been paying attention, you might be asking, how did I get -7 so fast on my graph? Well, it's the y-intercept. It is the constant. Let me prove that to you. 0 to the third power is 0. 2 times 0 is just 0. 0 squared is 0. 0 times 4 is 0. 5 times 0 is 0. And then you have -7. So the answer is just going to be -7 when x equals 0. And that makes sense because this order pair here is 0, comma, -7. The x is 0, the y is -7. The output or the answer is -7. Okay, I told you guys skip the projectile, skip 5, skip 6. Number 7, use the table of values of the function f of x equals x squared minus 8x plus 20. Complete, to complete the sentence down here, right here. Okay, I gave you a hint is to graph it. So let's just go draw a quick graph. And I want to draw some tick marks on here. So 2, 4, 6, 8. So I'm counting by 2. If I can count by 2 there. And this is like 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2, 8, 3, 5, 4, 4, 5, 5, and 6, 8. What do we have here? What does it look like? It looks kind of like a quadratic. Well, I already know it's quadratic because it has a power of 2. And again, if you wanted to, it's going to go up here really high at 20. Okay, now, it's saying the relative minimum. Minimum is the low point, and relative just means based on what we see here. Well, the lowest point here is in orange, and that order pair is 4, 4. So you might say near 4, but it is exactly at 4. The word near 4 might mean like 3.9 or 4.1, and that's not the case because you can use a graphing calculator, you can put in the function, and you'll recognize that at 4, 4 it is the lowest point on our graph. Okay, so number 7 was A. 8 and 9, and number 8 we skipped. Number 9 is each expression a polynomial. So a couple of things here. Remember the exponents should be whole numbers. So that means no negatives. That's really messy. Fractions or variables, like 2 to the x power. That's an example. Or x to the 1/2, or x to the -3. Does that make sense? Okay. So here, this one looks good. This is a polynomial. Okay, you can have a fraction as the leading coefficient, so that's fine. That one's a polynomial. This last one there, I see a negative exponent, and that's what we just set up here. So this one is not a polynomial. Okay, number 11. What is the sum? So we already know sum is plus, and you could just move all this and line them up to be like terms, we call them. And I'm doing this vertically stacked, which I think is way better. Now all I have to do is add the numbers in front. Add the numbers in front. So this would be 16x to the third. Notice the exponent here does not change. Okay? -4 plus 2 gives me positive 2x squared. That is 8x, and this would be a positive 4. And response number 11 is A. Alright, let's move on to the next one here. Siri is designing a rectangular logo that her business will use in various places like business cards, posters, banners, and more. What expression can be used to represent the area? Area is length times width. Well, it doesn't matter if this one's called the length and this is the width, or you change them. Because the big idea is you're going to do with what math operation here. You're going to multiply them, right? Multiply. So let's put it into the box. This is called the area model. And hopefully you're using it because it's very similar to what we've been doing when we were learning to factor. We're going to multiply first, and then we're going to add or combine like terms. So I get 12x squared. 3x times 7 is 21x. 2 times 4x is 8x. And 7 times 2 is 14. So we've multiplied. Let's now add. I'm going to add these two together. So that'll give me, let's double check, 12x squared. Okay, I have all those there. Then if I combine like terms, I get 29x plus 14. That means it's only going to be this one. Response number 12 is D. Question number 13. Determine the quotient. So quotient just means to divide. You could do this by long division any way you want. I'll show you by long division. Okay, here's the wrong part with using long division as I start the problem. It's not the most efficient. Why? Because in long division, did you notice this big space I have? You would have to put a placeholder for every missing exponent. Do you see this? This would just be painful. So division here is each of these terms are being divided by 8x squared. Because remember now in fractions, this is how you're adding this together. You can add the fractions if they have a common denominator. So it will look something like this. These are equivalent. So to work with this one, I'm going to break it up into the factors of what I have in the denominator. What does that mean? I want to have an 8 and an x squared on the denominator up here. Well, in order to do that, that's x squared times x to the 6. Why? Because in exponents, when you're multiplying the same base, which is x, you add the exponents. So that would be 2 plus 6, which would give you the 8 above. have my 8x squared. Do the same thing over here. 16, so that would be 2 times 8, and I have my x squared. So 8 divided by 8 is 1. Remember, you're canceling factors, which means by multiplication. Between the two is multiplication. Okay, what is left? You have 7x to the 6, and then you have a 2. So your response answer for number 13 is B, and then number 14, it is C. Andre is dividing 2x to the third plus 15x squared plus 34x plus 24 by x plus 2. Okay, so what I like to do in these error analysis problems is just do the problem. Do the problem. All right, in doing the problem here, I'm just going to put x plus 2 right here. Okay, so after dividing 2x to the third, so this is what I would do, and I'm doing it by the first one here, x. This becomes 2x squared. Andre writes 2x squared as the first term of the quotient, so now you're putting the 2x squared, which we got, right, and putting it above here, and then we're multiplying by the divisor, so we're multiplying here and here. This would get me 2x to the third plus 4x squared. Now it says, what is the next step? Now, you need to subtract, so this would be 2 minus 2 is 0x to the third, which we don't need to write. And 15 minus 4 gives you 11x squared. And you bring this one down. Okay, so let's look what we have. After we multiplied, right? We multiplied, what do we do next? We subtracted 2x third from 2x third plus 5x squared. Okay, so for this one, you're not going to add. Now, I'll tell you why some teachers, and I don't, they actually change all the math. They multiply by -1, then they add down, and I think that's too confusing because you're kind of doing 2 steps at one. Okay, let's take a look at this one. You'll notice that this one is a plus, and that one's a minus, and it should be a plus. So our answer is going to be A. 2x third plus 4x squared. You're going to subtract that from what's above. Okay, question number 15. True or false? To divide 6x to the fourth minus 10x to the third plus 4x squared minus 9x third plus 3 by x plus 5 using synthetic division. So synthetic division, you're going to have to set that equal to 0. Subtract 5, and you get x equals -5. Now it says I place the -5 outside the box, or to the top left. And then you just take your coefficients. Well, that is true. Number 15 is, question number 15 is true. That is response number 16. Okay, question number 16. Bill is using synthetic division to divide 2 polynomials. His work is shown. Using Bill's work, which of the following is the quotient? So again, the quotient is your answer up here. This is your divisor, and this is the dividend. Okay. So we're looking for the quotient, and if you flip this, then you would have, what's different is that this one's called the 0, because you set it equal to 0, right? The quotient, or your answer we're looking for in long division, is up here. And then for synthetic division, you have the coefficients of the dividend. Coefficient. Okay, so we're looking for this. How do you interpret this? Well, you can do the problem. Go ahead. You have, and the big idea of what synthetic division does is it reduces the power. Reduces the power. You can't see that. Reduce the power or the degree. So what you can do is you can count backwards. Okay, 20 here is a constant. 17 you just add an x and then keep going. Then you're going to add an x squared. So 3x squared plus 17x plus 20. You have two choices down here. And then the question is, what do you do with that negative 4? Well, that's correct. Look, negative 4, negative 4. Okay, what's the difference here is that this one, you already know that x equals 3. Well, how do you go to make it a binomial? Well, you subtract 3 and you get x minus 3 equals 0. So the denominator here should be x minus 3. So the answer would be D. Question number 17, complete the row of Pascal's triangle that we used to determine the expression a plus b to the 4th power. Well, you could just quickly make one. Add those two numbers, add those two. You have 4, 6, 4, and 1, and then keep adding. Okay, so the degree will match this one, 0, and you can use this row here as well. And if you're looking to the 4th power, you would find these numbers. So, I have 1, 4, 6, 4, and 1. Another way to know that that's the correct answer is because you already started with 1 and 4, so I have to have 4 and 1 on the right side of their Pascal's triangle. So what is nice is that they didn't ask us to actually expand it. 18 skip. Question number 19. Find the missing term in the expansion of y plus y, w plus y to the 5th power. Okay, so this one's going to be pretty. Something that I noticed is you have a 1, 5. Okay, just go back up to ours. Let's use a different color. 1, 5, 10, 10. So we should have a 10 and 10. I don't have to do the rest of the problem. And the answer is going to be C. Does that make sense? And you can, of course, expand it out and do the rest of the problem. But that was pretty simple because I already did it on the previous problem. So that was our Module 2 test corrections. We'll see you guys later.
Thou shalt not covet thy neighbor's paper, nor anything that he has. I love math.